Welcome to this explainer. Today we're taking a journey, but not across the globe or even out into the vastness of space. Nope, we're going straight inward. We're going to look at the very building blocks of your existence. So get ready for a massive perspective shift because the numbers, the science, and the sheer scale of what makes you, well, you, are absolutely staggering.
Okay, let's dive right into this. Do me a favor and just take a quick second to look at your hands. Flex your fingers. What are you actually looking at? We tend to think of our bodies as solid, permanent things, right? Flesh, bone, blood. But if we zoom in past the cells, past the molecules, all the way down to the atomic level, the reality of what you're carrying around every single day becomes incredibly strange and honestly fascinating.
Now, I really want you to pause and just try to take in this phenomenally massive number. 6.5 times 10 to the power of 26. That is a 65 literally followed by 25 zeros. It's a number so large the human brain can barely even process it. But it's profoundly personal to you, because this is the exact number of carbon atoms inside your body at this very second. Roughly 700 septillion carbon atoms.
Let's bring that mind-bending math back down to earth for a second. If you weigh, say, around 70 kilograms, that's about 154 pounds, all those septillions of carbon atoms weigh in at roughly 13 kilograms. That means carbon makes up a massive 18.5% of your total body mass. It's the second most abundant element in you, right behind oxygen. But why carbon? Out of all the elements in the universe, why is this specific one the literal foundation of our biology?
Section 1. Why life chose carbon, the ultimate biological Lego brick.
So carbon actually has a sort of chemical superpower. It's tetravalent. Basically, that means it has 4 valence electrons. Think of carbon like a Lego brick with 4 incredibly strong, versatile connection points. Because of this, it forms 4 covalent bonds to complete its outer shell. But the real magic here is catenation, its ability to bond strongly to itself. It can form long, stable chains, intricate branches, and complex rings. It is the absolute perfect flexible backbone required to build every single organic molecule in your body.
And this brilliantly explains why life went with carbon over its elemental cousin. You know, you've probably seen those classic sci-fi movies featuring silicon-based life forms from other planets. Silicon is structurally similar. It's also tetravalent. But there's a fatal flaw for complex biology. Silicon forms much, much weaker bonds with itself compared to carbon. The complex, delicate, and massive molecular chains needed for life to exist just fall apart if you try to build them with silicon. Carbon is uniquely perfect for the job. Now we know we have 13 kilograms of this ultimate building block to work with.
Section 2. Where it all hides. The blueprint of you.
Now, what's really fascinating about this breakdown is the missing element. Water accounts for the vast majority of our total body mass, right? But water actually holds absolutely 0 carbon. Instead, almost all of those 700 septillion atoms are packed entirely into your fat and your protein.
Let's actually walk through the exact math here using the standard reference man model. If we look at the numbers for fat and lipids, fats are by far the most carbon-dense components in the human body. They're made of these long fatty acid hydrocarbon chains. They're roughly 76% carbon by mass. Proteins come in second, at about 53% carbon. So when we talk about the structure of your muscles, your organs, and your cell walls, we're overwhelmingly talking about carbon scaffolding.
Section 3. Mind-bending cosmic scale, making 10 to the 26th tangible.
All right, it's time to truly comprehend the vastness of the atoms you carry around every day. 200 billion. That is the estimated number of stars in our entire Milky Way galaxy. It's a number so large that gazing up at the night sky barely even scratches the surface of it. Keep that number in the back of your mind.
Next up, 7.5 quintillion. That right there is the estimated number of individual grains of sand on all the beaches and in all the deserts on planet Earth.
So here is the absolutely crucial point. 6.5 septillion. The carbon atoms inside your body right now outnumber the stars in the Milky Way by 3 quadrillion to 1. No, seriously. You personally contain 90 million times more carbon atoms than there are grains of sand on Earth. In fact, your body's carbon equals the atoms in roughly 14 million entire grains of sand. You are literally a walking, breathing universe of matter.
But, let's pull back from the cosmos for a minute and ground this massive mathematical count back into the mundane. To hold 13 kilograms of pure carbon in your hands, you could picture carrying a standard car battery,
or maybe a large sack of potatoes. Or, if you want to think about pure graphite, the carbon inside you right now is equivalent to the cores of roughly 8,700 standard wooden pencils.
And that brings us to a really fascinating hypothetical. Since diamond is really just pure carbon arranged in a dense crystalline lattice, what would happen if, by some sheer magic of physics, we extracted all the carbon in your body and compressed it into a pure diamond?
Well, the answer is absolutely incredible. You'd produce a 65,000-carat gem. It would have a volume of about 3.7 liters, making it roughly the size of a large grapefruit. To put that into perspective, the famous Cullinan diamond, which is the largest rough diamond ever found on Earth, was just over 3,100 carats. Your personal carbon grapefruit completely dwarfs the greatest geological treasures on the planet. Section 4. You are a standing wave. Time and space.
Okay, let's shift gears and look at the origin and the flow of these atoms. First off, you need to know that your body is literally radioactive right now. Yeah, for sure. In nature, about 1 in every 1.3 trillion carbon atoms is the radioactive isotope carbon-14, which is created when cosmic rays hit the atmosphere. Because of this, roughly 3,700 carbon atoms decay inside your body every single second, turning back into nitrogen. Dozens of those radioactive decays are happening per second inside your very DNA. And by the way, this exact decay rate is the mechanism behind radiocarbon dating, which won the Nobel Prize in 1960.
So where did those 6.5 septillion atoms actually come from in the first place? Well, the Big Bang only created hydrogen, helium, and a tiny bit of lithium. Actually, scratch that. 0 carbon. Every single carbon atom inside you was forged through the triple alpha process, where helium nuclei smashed together at 100 million Kelvin inside the aging cores of red giant stars. When those stars died and went supernova, they violently scattered that carbon across the universe. You are literally, undeniably made of stardust.
But here's the kicker. You don't keep those specific stars' atoms forever. Back in 1953, Dr. Paul C. Abersold used radioisotopes to prove that our bodies are in a constant state of atomic turnover. Every 1 to 2 months, half of your body's carbon atoms are swapped out through breathing, eating, and excreting. Over the course of a single year, roughly 98% of all the atoms in your body are entirely replaced. The carbon making up your heart right now was, relatively recently, in the soil, in plants, or floating in the oceans.
This wild reality was beautifully summarized in the 1953 Smithsonian Annual Report. It noted that, biologically speaking, the body is less a fixed object than a standing wave that matter flows through, kind of like a whirlpool in a river. The shape remains, but the water, the matter, is completely different from moment to moment.
So considering that almost every single atom of carbon that structured your brain, your heart, and your hands last year has since left your body and been replaced by atoms from the sky and the earth, are you even the same person you were a year ago? It's a staggering reality to carry with you. Take a look at your hands one more time and just let that sink in. Thanks for joining me on this explainer. Keep wondering and keep learning.